This is really practicing using our formulas. So remember, we have a lot of formulas at this point. We have the general addition rule, and we have the addition rule for mutually exclusive events. We have our multiplication rules with regular and conditional probability. So we have a lot here. My suggestion to you is get used to using this formula sheet. That's the piece that you have at your disposal on everything you do. So start using it. Know how to look at that and use it to answer your questions. If I'm looking at this problem, I have a probability of A, probability of B given A, probability of A and B. So look at your formulas for chapter 5. What formula involves those three things? All right, so that one says the probability of A and B is probability of A times the probability of B given A. Are you guys okay? The formula sheet has E's and F's. Are you guys okay with me swapping out A's and B's? Okay. So now we just sub things in. So the probability of A is 0.7 times probability of B given A is 0.4. So we get probability of A and B is 0.28. So if you're struggling on problems, what I recommend is start writing out the statement. Now, what am I given in my problem? Write out the formula that you're using, and then plug in my stuff. So the next one, we have probability of B, probability of A and B. I want the probability of A given B. So what formula? We could do the same thing. There's a couple options, but couldn't I do the same one? So this is the probability of A and B. Now the way I wrote it last time, it had probability of A times probability of B given A. But that is the same as if I did the probability of B times the probability of A given B, right? Just if I flipped the A and B here. So this time we have the probability of E and the probability of A given B. So A and B is 0.4. B is 0.5. Probability of A given B, we don't know. So we divide by 0.5. So the probability of A given B is this one. I have probability of A, B, A or B. I need A given B. Is there any formula that involves all of those? Okay, so we might have to use a couple formulas this time. If I need the probability of A given B, what are my options for that? We could use a couple different ones. So you could use the multiplication one that we were just doing, the condition, or we could do the conditional probability rule. Okay, either way. So if I did the conditional probability rule, that says the probability of A given B is the probability of A and B divided by the probability of B. Right? Do I have all those things? If I were going to do this, I need the A and B first. So how could I get that? How could I find probability of A and B? That only works if I know that they are independent. I don't know that. Look at the other stuff we're getting. Okay, so I need a formula involving A and B. probability of A or B is probability of A plus probability of B minus the probability of A and B. So if I plug in that stuff, the OR is 0.66, probability of A is 0.4, probability of B is 0.3. So if I solve this, we get the probability of A and B to equal 0.04. So now I can plug that into here. And what's that give me? I got 0.133. So it's not just a guarantee that it's only a single formula. Sometimes we have to use a couple. Just a couple more. Okay, probability of A or B is 1. The probability, when it has that bar over the top, it means not A and B, or the complement of A and B, just another notation, is 0.7. And the probability of not B is 0.4. So how would I find the probability of B? Yeah, 1 minus probability of not being in B, because they're complements. Okay. If not A and B is 0.7, can you tell me what the probability of A and B is? 0.3, 1 minus 0.7. Okay, so now I really have the probability of B, A and B, A or B. So to get just the probability of A, I'm going to have to use all of these things. So I could do probability of A plus probability of B minus probability of A and B. And that is the formula for A or B. Plug in what we have. Probability B is 0.6, A and B was 0.3, A or B was 1. Subtract that over, so the probability of A is 0.7. So A given B. A couple different options. If you do your conditional formula, the probability of A given B is probability of A and B divided by the probability of B. A and B, we said, would be 0.3. Probability of B is 0.6. So we get 0.5. These are tricky. It takes a lot of practice. The more you do, the more familiar you will get with the options and how to solve them. It's not necessarily the math that's hard. We're just adding, subtracting, dividing things. but being able to plug them into the formula is tricky. And that's really just a skill that comes with practice, which is why I told you we're taking several days and just working on this before we move on. Yes.
Never mind. I can't believe it.
Sure. So I told you yesterday the 5.4 homework was due at the end of class today. So if not 5.4. So if you have questions that you need to be asking, you have time to do that. I asked you to go ahead and try everything so you knew what questions we had. 29B. Okay.
I have the right answer. Well, like I have the right answer. I know how, like they got it, but I don't know.
Makes perfect sense. Alright, do you guys want to look at that one together? Does it bother anybody? You ready to take your test? Alright. Are you guys okay with the others? If you didn't look at 29, then don't ask me to work it out. But if you tried it and didn't get it, then I'm happy to look at it. Do we need to look at A, B, or C? Or is it just B? Just B. Okay. So it tells us we have a bag of 30 tulip bulbs. And in that, we have 12 red, 10 yellow, and 8 purple. Alright, so D wants probability that one is red and the other is yellow. So we are taking 2 bulbs out of here. And I want one of them to be red and one to be yellow. Okay, so that means the first one can be red and the second one could be yellow. Or, what's the other way I could get one red and one yellow?
Yellow.
If the first one were yellow and the second one was red. We agree with that? Okay, so red and yellow. What is the probability that the first one I pick out is red? 12 out of the 30. Okay, if I took out a red, now there are 11 reds remaining. How many bulbs are in the bag? Not anymore. There's 29. How many of those are yellow? Still 10. Okay, so this is the probability of getting a red and then a yellow. Or means what when we're finding probabilities? Addition. Alright. So the other option, we have our whole bag. So how many bulbs do we have in here? 30. How many of them are yellow? Alright, so if I took out one yellow one, now how many reds are in my bag?
12.
Out of how many total bulbs? So you do that calculation and get your answer.
I don't know what I did though. Well, I did 1.1379 times 2.
Because that gave you the right answer. Are there any others that you want me to talk about? 21 and 35? Okay. So 21, suppose you just received a shipment of 6 televisions and 2 are defective. So we have 6 total TVs. That means 4 of them are good, 2 are not. If 2 televisions are randomly selected, compute the probability that they both work. So that means we get a good one and another good one. And tells me we're doing what? Multiplying. What is the probability that the first TV is good? How many good TVs are there? 4 out of how many total? 6. And so we're going to multiply. If I took out one of the good TVs, now how many good TVs are there? Out of how many total? So if we do that, 12. Is that 0.4? And it says, what's the probability at least one does not work? So, at least one bad one might mean the first one's bad and the second one isn't, or the first one is and the second one's not, or they both could be bad. Isn't that just the complement of them both being functional? So all we have to do is 1 minus the probability that they both work, and we get 0.6. So 40% chance that they both work, 60% chance that at least one does not. Does that make more sense? $35. Alright, the following data represent the number of different communication activities used by a random sample of teenagers over the past 24 hours. Part A. Are the events male and zero activities independent? Right, that is a little bit harder just to look at and see. Remember yesterday when we talked about independence, I said if things are independent, then knowing one thing happened does not change the probability, right? So the probability of the student being male is the same as the probability of them being a male, given that I know they had zero activities. So the regular probability is the same as the conditional. That is the definition of independence. So let's check these two. What is the probability of being a male? So how many males do we have? Out of how many total? Okay, so there's 0.5 for the probability of being a male. A male given zero activities. That means I already know there were zero activities. That is my denominator. So zero activities, how many students? No. The total for zero activities, 42. If you cover up the rest of that table, if you're not looking at the table, this probably doesn't make any sense. Everybody needs to open up to page 288 and follow along here. When we know a condition, that's all we are looking at. So I'm only looking at that column that has zero activities. So there were 42 total. How many of those were male? So we get 0.5. Those are the same, so that means yes, those are independent. Because even if I know they didn't have any activities, it did not change the probability of being a male. B. I want to know if female and 5 or more activities is independent. If they're independent, that means the probability of being a female would be the same as the probability of being a female given they had 5 or more activities. So, probability of being a female is what? We have 200 females out of the 400 total, so 0.5. Female given 5 or more activities. So that means my denominator is the 5 or more. Cover up the rest of the table. You are only looking at the 5 or more. How many did we have in that group? 71 females out of 109 total. Okay, 71 out of 109. What's that equal?
1.65,
What did you say?
1.65, 1.4.
Yeah, not 0.5. So they're not the same. So those are not independent. So they became, if I knew they were in 5 activities, they became more likely to be a female. C. Are 1 to 2 activities and 3 to 4 activities mutually exclusive? Mutually exclusive means what? No overlap, none of the same. Is it possible for someone to be in the 1 to 2 and the 3 to 4? No, either you were involved in 1 to 2 activities or you were involved in 3 to 4. You couldn't fit in both groups. So are those mutually exclusive? Yes, they can't be in both groups. Right, D. Are the events male and 1 to 2 activities mutually exclusive? So is it possible for a student to be male and be 1 to 2 activities? Yes, so that means they are not mutually exclusive. They can be both. Does that make sense? Okay. So whatever you have left on the assignment, you need to work on that first. That's your first priority. We'll grade it at the end of class so you can ask questions, check it, all that good stuff. What I have for you after you finish those book problems is a handout. And this is the first of a series of probability handouts that we have to come. So we're just practicing that. Nothing new,